Now we will discuss frequency graphs. These frequency graphs are going to be our cumulative frequency graphs. We're going to talk about cumulative frequency and cumulative relative frequency. Both these types of graphs are going to be graphed using the midpoint column and a new column that we're going to add to our table, or two new columns that we'll add to our table, the frequency column and the cumulative relative frequency column. The cumulative frequency graph, or the cumulative polygon we're going to make, the frequency polygon we will make, will be a rough outline of the histogram. And it's going to plot the frequencies, the cumulative frequencies, against the midpoints of each class. It should start at the x-axis and it will end at the x-axis. And you'll see it's a polygon because it's a closed figure when we're done. The other graph we're going to make is the cumulative relative frequency graph, which is going to show us the percentages over the classes. And to find cumulative, the word cumulative means to add up to a class. So we're going to add up to a certain class. We're going to plot that against the midpoint. And we're going to get this graph that is always either constant or increasing on intervals. So notice a frequency polygon starts on the x-axis, ends on the x-axis, and it's going to be a rough shape. So all the midpoints plotted against their cumulative frequency. This will give you a rough shape of the actual histogram itself. For an ogive, which is a cumulative frequency graph, it's going to plot the midpoints against each one of the cumulative relative frequencies or percentages, and it's going to give you certain values that you normally can't see, such as one of the values you're going to look at is going to be the median, which is the 50th percentile, or 50% of the data. To create these graphs, we only need to add a cumulative frequency row and a cumulative relative frequency table. Cumulative frequency means added up to a class. So this is how this works. We'll start in our first class, which is the 65 to 105 class, and notice that we have a frequency of 6. To calculate the cumulative frequency to the next class, so we're going to calculate up to the next class, which basically means you're calculating from 65 now to 145. How many values have you accumulated? Well, you had 6 in your first class, and then you're adding in another 8, so it's a total of 14. So in your second class, the cumulative frequency is 14. In the third class, so now you're adding up all the values from 65 to 185. How many have you accumulated now? Well, you have 6, 8, and another 6. So you're really adding whatever you got here, which is 14. You're going to add this to that, and that'll go over here. So this is going to be just 20. And in the next class, you're going to add whatever you got here to this, and this is going to go over here. So 20 plus 5 is 25. And then the next class, you're going to add 25 plus 2, 27. Then the next class, 27 plus 1, 28. And in the final class, 28 plus 2 is 30. You should have all of your observations add up in that final class. So this is the cumulative frequency, and notice it's up to a class. So what percentage of the observations were up to 225? Well, you can look and see that up to 225 is sitting here, which means you had 25 observations up to 225. The other thing we're going to add is the cumulative relative frequency column. Cumulative relative frequency is just like relative frequency, except now you're adding up to the classes again. There's two ways you can do it. We could add up 0.2 to 0.267 to 0.20 to 0.167 to 0.067 and add those values up to each class, which would work for everything. A much simpler way, though, because we have our cumulative frequency sitting here, is just divide these by the total. So 6 out of 30, 0.20. 14 out of 30, 0.467. 20 out of 30, 0.667. 25 out of 30, 0.833. 27 divided by 30, 0.900. 28 divided by 30, 0.933. And then If you add the last one, which will be 30 out of 30, that's equal to 1. If you were to add all these up, you're adding 0.2 plus 0.267, that's 0.467. Plus another 0.2 is 0.667. Plus another 1.67 is 0.833. And it's going to add up all the way down. And if you add up this relative frequency column right here, you should get the same thing you're getting here. So to create these graphs, we're going to start with the frequency polygon first. And what we're going to do for both the graphs, actually, is write the midpoints on each one. So here we know our midpoints were 85, 125, 165, 205, 245, 285, 305. That's it. Now, to construct the frequency polygon, on the x-axis, we're going to put our midpoints. Notice the midpoints are 85, 125, 165, 205, 45, 285, and 305. We're also going to start this with the lower bound, the minimum value, which was 65, and end this with the maximum value, which was 345. We'll plot each frequency against their midpoints. So in the first class, the frequency was 6. Plotting into the midpoint is 85, like this, 685. The next one is 120. The next one was, the midpoint was 125 and the frequency was 8. Then we had, the next one was 165 for the midpoint with a frequency of 6. Followed with 205 with a frequency of 5. 245 with a frequency of 2. 285 frequency was 1. 305 frequency was 2. You start at the minimum value and you're going to draw lines up to your frequencies. And it's basically a line plot where you're connecting the dots. And you always start and end at the x-axis like this. This graph is a rough sketch of what the histogram looks like, if you recall. Our histogram looks something like this. What this graph does is provides the shape of the histogram and gives you information about where were the relative increases the greatest at. For instance, you can notice that you had a large increase to start off with, and you hit your peak and you started to come down from there based off this graph. An ogive takes into account the cumulative relative frequencies, which are percentages. So you're going to put the midpoint again on the x-axis. This time, though, when you start this, you'll start with the y-axis being percentages. And you want to calculate the percentage of each value in every class. So using the cumulative frequencies, we can see that in the first class, the midpoint is 85, and the percentage of values at that first class was 0.2 or 20%. Then we increase to 0.467 in the next class. So we'll put a dot at 125, 0.467. Then the next increase went to 0.667. Then we went up to 0.833, 0.90, 0.933, and finally in the last class we're at 1. So this graph does this, and again it's a line plot that you just connect. Except this line plot is either always going to increase or it remains the same. If it remains the same, that means there was no values for a particular class, meaning that the frequency didn't change from one class to the next. So straight lines or constant lines mean that there were no values inside of a particular class that you're passing over. From this graph, we can tell these things. Because this is a percentage, if we want to know the median or the median class, the median class sits here at 50%. Now, if I draw a line to this graph right here, I know that the median occurs somewhere right here. And I bring it down to this. What this tells me that the median had to occur in between these two midpoints, 125 and 165. Or if we go to our table up here, we know the median had to occur somewhere between here and here. And if you can see this, as you see, we went from 14 to 20. Well, half of the 30 values is 15. 15 has to sit somewhere inside of this class right here. So the median actually occurred in the 145, 185 class. That's one thing we can read from this graph. We'll be able to read certain other percentages, such as the 75th percentile, which comes right here. This is called Q3, and we'll talk about that later. But it occurs somewhere out here. And then we have the 25th percentile, which is called Q1, and it occurs right here. The median, Q1 and Q3, are also known as percentiles. A percentile tells you how many values fall at or below a specified percentage. So the 50th percentile, or the median, tells me that 50% of the values fell at or below this value. Q1 is called the 25th percentile. And what that means is that 25% of the values fell at or below this value. Q3 is called the 75th percentile. And what that means is that 75% of the values fell at or below whatever this value is.